Hello and welcome back to I Have No Idea What I Am Doing. In this episode, we look at fixing the data structure from the previous episodes. Yes, and I know we changed the data quite a lot, but that's all part of learning. Coincidentally, if you didn't see all the nightmares we had with structuring arrays, you can find out that in the previous episode. And if you've not watched any of the episodes, the playlist's going to pop up just about here. No, it's up here. I've done this several times now and I keep forgetting what side of the screen it is. If I've done my job correctly, I should have pushed the branch up. There's an episode 6 branch up there. There's an episode 1, 2, 3, 4 and 5 branch up there. So you can pick up from any video. It's really nice. Or you can just follow along and check out the master branch. It should be up to date with this episode now. So without any further ado, let's get learning. Those of you who watched the previous episode, I'll know we ended on a little bit of a dilemma. What we did have was the ability to move cards from the deck into the hand, then the hand into the play area, and then the play area back into the deck. And that all works pretty well. You can see moving a card from the deck, pulls it into here, and then into the play area. And we turn them all over, and then everything moves back to the deck. And then we can pull them in, and the cycle continues. However, you will notice that we have these cards set to IDs instead of the text. Now this is because I had noticed a small problem where the order of the cards was sort of fixed. So basically, if we sent card 8, 9 and 7 over to the play area, you would expect it to be card 8, 9 and 7. Really, it's actually cards 7, 8 and 9 because the order, it's sort of auto-ordering them. And then similarly, when you send it back to the deck, it sent it back in an order as well. So when we get it back from the deck, we get card 7, card 8 and card 9 all in order. This is obviously not great for a card game because if you put a card back in the deck, you're not getting the least recent card or the oldest card when you draw from the top of the deck. You're actually just getting the card with the lowest ID, which is not what you want at all. The cards with a higher ID are just never going to get drawn from the deck. This was basically because of a problem we have with the way we organise the data. Again, if you've been watching the series, you'll know we've had a lot of issues with the data. The data is very important. Hopefully we're going to get it nailed today. So what we did have was just one big array that had all of the cards, all 10 cards in this case, and the cards would have an ID, some text, a position, and whether they were face up. We're not actually using the face up stuff anymore, so I'll take that out when we clean this all up as well. But the important part is this position here. So when we're moving a card from the hand to the play area to the deck, and when we're moving the card from one pot to another, essentially, we're not actually physically moving the card at all. We're not moving it from one array to another. We're just changing this position variable inside the array. So moving a card, let's say we've got this card here. We want to move it from the deck to the player's hand. We don't actually move this data at all. We just change position here from deck to player 1. So that's kind of where the issue stems from, because the order of these never changes. It will literally just change a flag. So we had a few ideas of how to tackle this. To sort of condense it a little bit, this is where we were before. So we have 2 cards here with an ID, some text and a position, and these are both currently in the deck. And when we call move card to, we pass it card 000 for the card ID and hand for the destination, and then that will move card 000 to the hand. And it does this by changing the position on card 000 to hand, and then that's it. So you see, this is what we have currently, and it doesn't work. So here was my first idea. Now, don't judge me on this. It was pretty terrible idea, but it's one of them ones that seemed like a great idea at the time until you actually think about it. But I'll take you through it anyway. So my idea was to have a location variable on the objects as well. Not to be confused with position. This is the first flaw in the plan. The names they're going to clash. But this tells you what position the card is inside the collection that it's in. So these two cards are again in the deck. This is at location 0 and this is at location 1. So you would have card 0 and then underneath it you would have card 1. And if you were to swap that for location 1 and this for location 0, the cards would swap. So we can have a bit of order in there and that it would work. Then when we call move card 2 in exactly the same way, we would move card 0, 0, 0 to hand. So card 0, 0, the position is now hand. The location within that is 0. And the card 0, 0, 1 is still in the deck, but the location is now changed to 0. The idea was that I would just add the location thing to be whatever the length of the amount of cards in that collection was. So, for example, with this one, it would have a length of 2 because there's 2 cards in it. So the next card to go in there will be location 2. And that part works, but you get the issue of, like we have here, when we've moved card 0, 0, 0, we then have to loop through every other card with a location greater than the one that we've got and -1 from it. And that's going to get messy quick. So, enter idea number 3. This one works a little bit differently. What I wanted to do with this is the easiest way to get the behavior of an array is to use an array. So my plan was we would have different collections. So we would have all the card data exactly the same, but the collections would have references to these cards. So we can say card 0, 0, 0 and card 0, 0, 1 are both in the deck because the position is set to deck here. And then when we move card 0, 0, 0, 1 to the hand, I don't know why I've changed this will be called in the same way as the other ones. I don't know why I changed the data there. But when we move card 0, 0, 0, 1 to the hand, 2 things happen. The reference inside card 0, 0, 0, 1 changes to hand, and the collections changes, drops it out of deck and puts it in a hand. And that will work. That's a fairly solid solution. The problem being, I don't like the idea of essentially storing the same data twice. If somehow the data gets corrupted and that changes to deck, then where's the source of truth here? Is it in the deck, like this says, or is it in the hand, like the collection says? It shouldn't happen, but shouldn't and doesn't aren't necessarily the same thing. Then I had an excellent idea. What if I was thinking about this wrong? What if I had the mutation slightly wrong, and instead of just saying move this card to somewhere, I say move this card from somewhere to somewhere? The data is now even simpler. We have a deck with a series of cards. We have a deck with a series of cards that just have an ID and some text. There's no location, there's no nothing. And then we say move card 2, and we don't just pass it a card ID and a destination anymore. We have a card ID, we have an origin, and then we have a destination. So we would say move card 0, 0, 0, 0, 0, 0, 0 from the deck to the hand. And then that would update the data to look like so. It mirrors a lot more closely to what's actually happening as well. So we are now actually moving it from one place to another rather than just changing a flag. This has a number of benefits. There is a definitive list of where you're getting the cards from. We can create arrays on the fly. There's no, we're not too bothered about if a new player joins. We just create a new array for that player. We do have to be a little bit careful where if a player disappears, the cards that the player had need to go somewhere. They can't just disappear because then we lose cards forever. No one wants that. But there's ways around them things, and they're a lot simpler than the ways that we'd need to code around for the other ideas. So this is what I'm going to do with the data. I'm going to do a quick cut, and then I'll come back with all the changed data, and everything should be lovely. Right, so that's the data updated. I've borrowed a little bit from idea 3 there, where we now have the collections and then deck, play area, and player 1. This is just so that I can have different things inside the card state without it clashing with any of these. Having the opening state as a sort of array is a bit weird, really. So I've just put everything inside this collections thing. Inside collections, exactly like we said, really, we've now got deck, play area, and player 1 as 3 separate arrays, which have objects which simply store an ID and some text. You'll notice as the series progresses, this data is getting simpler and simpler and simpler, and that's good. We want the data to be as simple as possible. Now, what you may also notice is that this side of the screen is now a lovely shade of red. That is because all our tests are now failing. The tests are failing because we've updated the data. What I've done is, inside the tests, I've updated the initial state up here to match exactly this. So we've got the same data structure to test, and then I've pulled that initial state in. I've just used the spread operator to basically, if I'd just done that, it sets these to be exactly equal to each other. So if I make any modifications on the state, it modifies this initial state, which is not what we want for testing, because tests can start to sort of influence each other. So putting it inside an object with this spread operator basically is a simple way of saying I want a copy of this state rather than a reference to it, which is good. That's what we want. Right. Because I've passed that state in, I can say our tests are failing. This is for 2 reasons. Reason 1, obviously, the code that we've written to handle the data and pass the tests doesn't handle the data structure in the way that we have just changed it to. Reason 2, we're expecting the results to be different to what they actually are. So you'll see on this one, it should filter the deck cards. We're expecting this kind of data, and that's not really what we want, because, like I said, the data has changed. So I'm going to update the assertions first, and then we can start writing the code that tests it. So what do we actually want? We expect the result to equal initial state dot collections dot deck. Okay, it should flip a card over. This is completely redundant now, as we are no longer storing the face-up value on the card data. So easy way to pass that test is to just delete it. Don't do this if it's a test you need, but it's a test that we no longer need to test for. It should move a card from the deck to the hand. We expect... What do we expect? Well, first of all, we expect state.collections. Where we're moving from the deck to the hand. Deck to have len of what number do we want? Well, it wants to be 1 less than what it was initially, so we shall do initial state dot collections dot deck dot length -1. we expect hand, because that's where we're moving it to have the initial state dot hand +1, because it wants to be one longer. And we also expect state.collections.hand state.hand. So the last element in the hand to equal. Actually, I'll do that ID. Oh, acorn, whatever that was. To equal. What do we want? There it is. Card ID. So that basically says we expect the deck to be one shorter than it was, we expect the hand to be one longer than it was, and we expect the last card in the hand to be that card that we've just moved, basically. So that will make sure that we're not inserting it further up in the array and getting the weird ordering that we were getting before. Right, tests are done. We just need to write the code that passes them tests. Hopefully this will be nice and easy. Getters. Previously we were doing state.filter, we were getting the card with the card position of location. We don't need to do anything anywhere near that complicated anymore. We just simply return state.collections location. So if we want the hand, we return state.collections.hand. I picked a bad one. Deck would be state.collections.deck, and it would just return this array. So in theory, hey, one passing. Smash in. Mutations. Turn card over. We no longer need to turn a card over, so that can disappear. That's fine. Now, mutation. Move card to. That's a good point. In the test, we're only passing it a destination, but we had previously said we want to pass an origin as well as a destination. So we'll update the test first. Origin, destination. The origin is the deck. Yeah. Okie doke. Right, the test will still fail because we've not updated this, but we now want to pull out of the payload the origin as well. The card, we would find it on the state. Do we still need the card? We do still need the card, but the card is in the origin collection. State.collections origin, and I want I also want the destination collection. Where the destination destination, and we no longer find the card in the state. It's in the origin collection. It sounds like a fancy furniture thing, doesn't it? The origin collection. Anyway, we don't update the card position. What we want to do is we want to do two things. We want to remove it from the origin and we want to add it to the destination. Adding it to the destination is the easiest one. We just do destination collection dot push card, and that moves it. This is good. This is good. Expect array for to have a length of 3 but got 4. That is because we also need to remove it from the origin collection. So we say origin collection dot, is it splice or slice? I can never remember. Index of origin collection, the origin collection, dot index of card, and just that one. Expected array 3 to have a length of 2 but got 3. Okay, why is that going wrong? Ah, I wonder, am I actually mutating the data here? I'm going to freeze it. Object.freeze. Now I can't mutate the data. Let's see, expected array 3 to have a length of 2 but got 3. It shouldn't be expecting anything to have a length of 2. Because initial state.collections.deck.length minus 1 should be... It should be 3. Don't get it. Am I mutating this data? I really shouldn't be. I don't see why I am. I am. So, as I was saying before, all that stuff about mutating the data and getting around it, it was nonsense. It was absolute nonsense. Okay, so I disappeared for a bit there because there was some weirdness going on with the tests. It's still happening, is the bad news. The good news is I know exactly what the weirdness is now. So I've split the tests out so that now we explicitly ask for if it should have one less card in the deck, it should have one more card in the hand, and should have the last card in the hand, the one we just removed. The test itself is exactly the same. I've just run a before each loop on all of these so that it's a little bit more helpful when the tests fail. It tells us exactly what failed rather than getting that weird array should be 4 or whatever that we were getting earlier. So what's happening, which is really, really strange, and I really don't get it, is so we loop through this move card to, and we say set the state to be a copy of the initial state, and then do your mutation, give it the state. Yeah. What should happen is the initial state should be entirely untouched. It shouldn't care because we create a copy of the initial state every single time. But what is happening is it's not being untouched. I don't get it. So you can see we're logging out the initial state collections hand length, and then we're moving the card from the deck to the hand, and every time we run it, the hand gets one card longer. I don't understand. I've worked it out. So, as I said, JavaScript is very, very weird. And we weren't actually deep copying the initial state originally. We were just shallow copying it. So what we do is we deep copy the initial state. Nice and simple. No, JavaScript doesn't just let us deep copy. I've wrote a helper function for deep copy. And it does it in a really nice way. Where we pass the stringified version of an object. And that... It's quite nice in a way. So it just turns everything into a string, which gets rid of all of your references. There's no references anywhere. It's just literally the data. And then it passes that string and is back into being an object. I can see this tripping me up somewhere, but for now it works. And as you can see, we have 4 passing tests. The good thing is, because we were very smart and we have decoupled our data and our components, the components do not care that we have just gone through all of this turmoil to get the new data structure working. It doesn't care that we've remapped the getters and we've remapped the mutations. It simply will still render, because all it's doing is it's saying, hey getter, get me the cards from the deck. And the data's changed, but so's the getter to say, right, okay, well, the data's changed. This is where we get the data from now. The card just says, I don't care where you get the data from. Just get me the data I'm asking for. So this all still works. What doesn't work is clicking on the cards anymore. And that's simply because we changed the mutation to ask for an origin. So we can hopefully add that in pretty easily. If we go to the deck, we've got the destination here. Origin will always be the deck. Similarly, hand, the origin will always be, actually it's not player 1, is it? It's player underscore this dot, oh, it's dollar props dot player ID. There's your origin. And what's the other one? Play area. We also want in here an origin of play area. So that's all hooked up now, and we should just have the simple adding the cards to there, nice and easy, and then move some of these into the, oh, I broke the styling, turn them all around, very, very good. Okay, that was weird. Oh, that's interesting. 1, 2, 3, 3. It's leaving one behind. Oh. Ah, right, okay. So what I think is happening here is it's looping through each of the cards and it's committing the move card to mutation for each card, but it's triggering the mutation and updating the state while it's still doing the for each loop, so it's missing cards. So okay, what I'm going to do instead, if I do this dot cards dot map, mutations, this dot cards dot map card, and I want to return, and then this dot mutations dot for each mutation, so store dot commit move card to mutation. Okay, so let's just write this correctly. Right, what I did there, so as I said, we were originally looping through each of the cards and then committing it in the loop, and then the loop itself was updating, so we were skipping cards. So all I've done is I've made a new array which maps through all the cards and it returns the payload essentially that we want. And then we loop through that array of payloads. So even if the cards do update, it doesn't matter, we're still going to loop through these because they're two separate arrays now. Right, so everything should be working. Take it from the deck into our hand, move it from our hand into the play area back into the deck. Lovely, right, and we have our game back. We can eat people and onions and everything and then we've got eat people, onions, everything, and then we put it in the deck, and then the deck gives us eat people, onions, everything. Eat people, onions, everything, send it again, librarian, salsa, going to bed, send it to the deck, people, everything, onions, librarian, salsa, and bed. Yes! Right. So, that was a bit of a roller coaster, really. There were lots of things went wrong that I didn't foresee, if I'm being honest. There were some quirks of JavaScript there, but we got over them and we worked through them, and that's the point. We're learning. If you learn it and everything goes right, then you've not really learned anything, have you? You're just doing what you would have been doing anyway. One thing that really helped us pick out these errors was our tests. They handled things rather nicely. One thing that we didn't test, and we didn't get caught in the tests, was when we were adding, removing the cards from the play area and putting them back into the deck. That loop was broken and it wasn't working. And it was a fairly simple fix once we knew what we were doing, but we didn't know it was happening. And that is because we were not testing the components. I'm not going to write the test for the components just now, because writing tests is a little bit boring and we want to do something fun. So what we're going to do is we're going to add in some animations. I've never done animations before, so this is proper learning for me. I have no idea what I'm doing. I realise there's a title of the show, but literally no idea of this one. Never done animations in Vue before. Okay, so basically that episode was just far too long. I've recorded all the animation stuff already, and when I started editing it down, it took it to like 60 minutes, which is just far too long for an episode. I vowed, as a result of that I must not make 60-minute episodes if I have no idea what I'm doing again. So, here's what I'm going to do. I'm going to split the episode straight down the middle, so we have two 30-minute episodes. The first one is going to be all the data stuff that we've just seen, where I look at the immutability, I look at some testing, and there's actually quite a lot of stuff in there. I'm going to write a little post about the immutability stuff as well, because there's a lot of information there that I only kind of touched on that I need to go away and research. The next episode is going to be all about the animations. Having already recorded this, I can tell you ahead of time that went a lot smoother than the first part of this episode. Vue animations are just really, really nice. The transitions, the way they're handled, it's good. Keep an eye out for that episode. It'll be coming along in 2 weeks. As I said, episodes are every 2 weeks, so the next one will be on the 8th of March. If you don't want to miss that, then just hit the subscribe button, which should be around here somewhere. As ever, if you have any thoughts, opinions, questions, or anything, really, just drop it in the comments below or follow us on Twitter at FrontendNE. Keep an eye out for my post about immutability, and until then, I will see you in 2 weeks. Just remember, I have no idea.